So, you've just opened Unity for the first time. You're staring at that blank project, a sea of intimidating windows, and you've got this incredible game idea in your head, but that first step feels like staring up at a mountain. Where do you even begin? Well, in this video, we're going from this blank screen to writing your very first C# script. By the end of this, you'll be telling a simple cube to move and change colors, getting a handle on the core building blocks for literally any game you want to create. This is the foundation, so let's build it together. Alright, first things first, let's get our workspace set up. If you haven't already, fire up Unity Hub and create a new project. A window is going to pop up asking you to pick a template. For what we're doing, the 3D Core template is perfect. Give your project a name, something cool like My First Game, and choose a spot on your computer to save it. Then, hit Create Project. Unity might take a couple of minutes to get everything ready, so now's a great time to grab a coffee. Once it's loaded, you'll see the main Unity editor. It looks like the flight deck of a spaceship, I know, but let's just focus on the 3 windows we actually need for now. Over on the left is the hierarchy. This is just a list of every single thing in your game's current scene. Right now, it's pretty lonely, just a camera and a light. In the middle, you have the scene view. This is your 3D canvas, where you'll visually build out your game world. And on the right is the inspector. Whenever you click on an object in your hierarchy, all of its details and components will pop up right here. Let's get our first actor on the stage. In the hierarchy window, click that little plus icon, head to 3D Object, and select Cube. Boom. A cube appears in your scene view and gets added to your hierarchy list. Now click on it and look over at the inspector. You'll see all its properties, like its position and scale. This cube is what we're about to bring to life. So how do we actually tell this cube what to do? We give it a brain. And in Unity, a brain is a C# script. A script is just a list of instructions. The cube is just a boring block of ones and zeros until we attach a script to it that says, hey, when I press this key, you move. Let's make that list of instructions. Down in the bottom window, the project panel, you'll see an assets folder. This is basically the filing cabinet for your entire game. Right-click inside that assets area, go to Create, and then select C# script. Unity will immediately want you to name it. And a pro tip here, always name your scripts without spaces. It'll save you headaches down the road. Let's call it Player Controller. Hit Enter. Okay, so we have a script file, but it's just sitting in our project, not connected to anything. To make it do something, we have to attach it to our cube. Select your cube in the hierarchy. Then, just drag your Player Controller script from the project panel and drop it right onto the inspector. You'll see it pop up as a new component at the bottom. And just like that, you've given your cube a brain. Now, it's time to teach it how to think. Go ahead and double-click your Player Controller script. This will open it up in your code editor, which is probably Visual Studio. You'll see some default code that Unity kindly generated for us. Let's figure out what this boilerplate stuff actually means. At the very top, you see lines like using Unity Engine. This is just us telling the script, hey, we're going to be using Unity's big library of built-in commands. Inside this class, you'll see 2 main functions or methods, void start and void update. Void start is called once and only once, right when you hit the play button. Think of it like a character's opening line in a play. You use this for one-time setup tasks, like setting a character's starting health or position. Void update, on the other hand, is called over and over and over again, once for every single frame your game is running. If your game runs at 60 frames per second, the code inside update runs 60 times a second. This is where you put stuff that needs to be checked constantly, like, is the player pressing a button? Inside, void start runs once for setup, and void update runs every frame for constant checks. Next, you've got public class player controller, MonoBehavior. A class is just a blueprint for an object's behavior. So, our player controller class is the blueprint for how our cube will act. The MonoBehavior part is the secret sauce. That's what lets Unity attach this script to a game object and gives us access to all its powerful features. Time to make this cube move. To do that, we need to introduce one of the most powerful concepts in programming, variables. A variable is just a little container for a piece of information. It could hold a whole number, int, a decimal number, float, some text, string, or a simple true/false value, bool. We want to control the cube's speed, which will probably be a decimal. So let's use a float. At the top of your class, right below public class player controller, add this line: public float move speed equals 5f. Let's break that down. Public is a magic word that means this variable will show up in the Unity inspector. This is awesome because it lets us tweak the value without ever coming back to the code. Float is the data type, move speed is what we decided to call it, and equals 5f is its starting value. That f is important. It's how you tell C# that 5 is a float, not an integer. So how do we use this to move the cube? Every game object in Unity has a transform component that holds its position, rotation, and scale. We can talk to that component from our script. Inside the update method, type this line: transform, translate, vector3.forward* move speed. Let's fix this. This is a classic rookie mistake, but the fix teaches us a crucial concept: time.delta_time. This is a tiny fraction that represents how much time has passed since the last frame. By multiplying our movement by this value, we switch from moving per frame to moving per second. This makes our movement smooth and consistent, no matter how fast or slow the computer is. Save your script and hop back to Unity. Now for the fun part. Press the big play button at the top. Whoa, the cube just shot off into the void. What happened? Well, remember update runs every frame. We told it to move 5 units per frame. On a decent computer, that's insanely fast. To fix this, we use time.delta_time, which represents the time since the last frame, making movement smooth and consistent. Go back to your code and update the line to this: transform, translate, vector3.forward* move speed *time.delta_time. Save the script, go back to Unity, and press play. Much better. The cube now glides forward at a nice, steady pace. And because our move speed variable is public, you can actually change the number in the inspector while the game is running and watch the cube speed up or slow down in real time. Pretty cool, right? A self-driving cube is neat, but it's not much of a game until we're in control. Let's make the cube listen to our keyboard. First, let's stop the cube from moving on its own. Go ahead and delete that transform, translate line we just wrote. Inside the update method, we're going to grab the player's left and right input. Add this line: float horizontal input equals input.getAxis horizontal. Input.getAxis horizontal is a built-in Unity function that listens for the A and D keys, or the left and right arrow keys. It gives us back a value between -1 for full left and +1 for full right. Now let's do the same thing for forward and backward movement. Float vertical input equals input.getAxis vertical. You guessed it, this one checks for W and S, or the up and down arrow keys. And there you have it. You're in control, and you're starting to see how just a few lines of code can create something interactive. If this gets you excited to learn more about things like physics, animations, and building a full game loop, check out the link in the description for my complete Unity for Beginners course. It'll take you from what you've learned here all the way to publishing your very first game. Now we can use these inputs to control our movement. Add these 2 lines right below the ones you just wrote. Transform, translate, vector3.right* horizontal input * move speed *time.delta_time, and transform, translate, vector3.forward* vertical input * move speed *time.delta_time. This is just like before, but now we're multiplying the movement by our input. If you're not pressing any keys, the input value is 0 and the cube stays put. Save your script and hit play. Use your WASD or arrow keys. Look at that. You have full control over the cube. You just built a basic character controller. You're in control, seeing how a few lines of code create something interactive. If this excites you, check the link in the description for my complete Unity for Beginners course. We've got movement down. Now let's tackle that other goal, changing the cube's color. If you look at your cube in the inspector, you'll notice it has a mesh renderer component. That's the thing that actually draws the cube on your screen and gives it color. Just like we grabbed the transform component, we can grab the renderer from our script. Our goal: turn the cube blue when we press the spacebar. To check for a key press, we'll use a simple if statement. Back in your update method, underneath your movement code, add this: if input.getKeyDown keycode space. input get key down is true for only the single frame you first press a key down. The code to change the color will go inside those curly braces. So, how do we change the color? First, we have to get the renderer component. It looks like this: get component renderer .material.color equals color.blue. Okay, that line seems like a mouthful, but let's walk through it. Get component renderer is you telling Unity, hey, go find the renderer component that's attached to this object. From there, .material.color just digs down to its specific color property. And we set it equal to color.blue, which is a handy preset color Unity gives us. Now let's stick that line inside our if statement. If input.getKeyDown, keycode, space, get component renderer.material.color equals color.blue. Save the script and head back to Unity. Hit play, drive around a bit, and then press the spacebar. Instant blue cube. To take this one step further, let's make the color customizable, just like our speed. At the top of your script where you declared move speed, add this new variable, public color new color. Now, go back to your if statement and replace color.blue with our new variable. Get component renderer.material.color equals new color. Save the script. Back in Unity, look at your player controller in the inspector. You'll see a new field called New Color. Click on that white box, and a full color picker will pop up. Pick any color you want. Now when you press play and hit the spacebar, the cube will change to whatever wild color you chose. Let's just take a second and appreciate what you just did. A little while ago, you were staring at a blank, intimidating project. Now, you have a controllable object that responds to your commands and changes its look on the fly. You've written a C# script from scratch. You learned about game objects, components, and variables. You know the difference between start and update, two of the most critical functions in Unity. You've handled player input to create movement and learned how to access other components to change their properties. And these aren't just parlor tricks to make a cube dance. These are the absolute, fundamental building blocks for almost any game you can dream of. A player's health bar? That's a variable. An enemy's patrol path? That's controlled in update. Firing a laser, opening a door, or casting a spell. It all starts with the exact concepts you learned right here. Don't worry if you didn't memorize every line of code. Nobody does. That's not the point. The point is to understand why it works. You can always look up syntax. The real skill is learning how to break down an idea into logical steps that a computer can follow. If you had fun with this and you're ready to build on these skills, make sure to like the video and subscribe. In the next tutorial, we'll use Unity's physics engine to make our cube jump and deal with gravity. Thanks for watching, and happy coding!